Welcome back again. So, uh, where I was discussing about the Fourier series and the representation of a function as a series of constant times, that is sine and or cosine terms of different frequencies. Okay. Now again, getting back again, periodic phenomena have long fascinated mankind. Our ancient ancestors were aware of a recurrence of phase of the moon and certain planets, the tides of a lake and oceans, cycles in weather. Even Isaac Newton calculus and his laws of gravitation enabled him to explain periodicity of the tides, but it was left to again Joseph Fourier and his successors to develop Fourier analysis, which has been profound applications, okay, in the study of natural phenomena and the analysis of signal and data. Again, if you I'll give you one example in describing the motion of planet about the sun. We use Newton's law to arrive at a differential equation involving the distance of the planet from the sun at any time. Now, what will be the mathematical solution for that? Once a problem has been successfully formulated in terms of equations, we need to solve them for the unknowns involved, subject to various conditions. We have conditions there, which are given or implied in the physical problem. One important consideration is whether such solution actually exists, and if they do exist, whether they are unique. For the differential equation, you will have the unique solution for the differential equation. That's what I was talking about. Now, Fourier, in attempting to solve a problem in a heat flow which has been formulated in terms of partial differential equations, was led to mathematical problem of expansion of functions into series involving sine and cosine. Such series, now called Fourier series, are the interesting form from the point of view in mathematical theory, in the later part of the chapter with, or the module which I'll be talking about. Now, what will be the physical interpretation? After a solution has been obtained, it is useful to interpret it physically. Such interpretation may be of value in suggesting other kinds of problems, which could lead to new knowledge of mathematical or physical nature. So, what we mainly concerned with the mathematical formulation of mathematical problems in terms of partial differential equations with the solution of such equations by method commonly called Fourier methods. The Fourier series are one type of infinite series that represent periodic functions in terms of cosine and sine, which I have already talked about. Fourier series are the greatest importance to engineer and applied mathematicians. To define Fourier series, first we need to do some background. the function is said to be periodic function. Okay, f of x defined for all x, possibly at some point. If there is some positive p, is called periodic function of f of x. Let me uh, put it to you in the board what I wanted to talk about. So let us see that. So how do we define what is a periodic function? So that is f of x plus p is equal to f of x. I get back the same function. Now, what is a periodic function? Let us see one example. That is, you have sine and cosine. These two are the periodic functions. If you get back the same function, it is called periodic function. Now, we have to know some of the functions which is even or odd functions. The function is said to be even when, let us see that once again, the function which is said to be an even function. Suppose if I have function f of x, okay, is said to be even. If you get back some function, if you have this as x again, f of minus x, you get back the function which is f of x again. So this is an even function. The graph of the even function is always symmetrical about the y-axis. Did you understand this? This is the first one. So if you have f of x minus x and minus f of x, so this function is said to be an odd function. Now here the graph of the odd function is always symmetrical about the origin. For even function, you have the graph of the even function is always symmetrical about the y-axis, and for odd, the function which is always symmetrical about the origin. Let me give you one example how to check whether it's an even function or odd function. Already I told you that is f of x, which I have cos function. So f of minus x, cos of minus x. Again, you get cos x. So this is f of x. So this is an even function. So this is the example for even function. Suppose if I have function f of x as sine x. So f of minus x, sine of minus x. So this is sine x minus x. That is minus f of x. So this function is an odd function. There are various possibility when you have more number of functions. So suppose if I have function f of x, if I define f of x as even, okay, and if you consider g of x, another function which is an odd, let us see the possibilities. There will be three possibilities here considered. Okay, so h of x, if you have now f of x into g of x, this results an odd function. Now, if I have h of x which is f of x into f of x again. So this results an even function. Both are even, so that is even. Here, one is even, one is odd, so you get odd. Again, h of x, which is g of x into g of x, if you consider, both are odd, so you get even. Now, whatever I have explained, let us take examples. Okay, so let us take h of x again, x square and cos x. Since I have another function which is h of x, which is x sine x. Now, both both are odd function, because this is minus x and as well as this is minus sine x. So this results an even function. Now, if I have another function which is h of x is x square sine x. Now this being an even function, now this being an odd function, now this results an odd function. So I hope you understood this. Now again, let us have any doubts? No, right? So let us again continue with uh, the functions which I was talking about. Is the value of the coordinate, each ordinates, f of x repeats itself at equal intervals. Okay, then that f of x is said to be a periodic function. That's what I said, equal to f of x plus p. Okay, and so on, uh, for if you consider the periodic function. Fine. Now again, let us look at uh, the partial differential equations. Is an equation containing an unknown functions of two or more variables and its partial derivatives with respect to these variables. Explain more deeper and try to understand the things which we are talking about, which is very important. The order of partial differential equation is the order of the highest derivative present. The solution of partial is any function which satisfies the equation identically. The general solution is the solution which contains a number of arbitrary independent functions equal to their order of equations. Right? Now, this was the theory about why Fourier series, and that's how it has been arrived. So, thank you for listening. Tune into some more videos which I'll be doing live. So, uh, I need your remarks on this or the comments on this, so that I'll continue in the next part. Okay. Thank you for listening once again.